So we're starting a new chapter. This is radical and rational functions. And the first section is on variation. I do believe that's what this says. Yes, variation functions. You use these in science too. First though, we have a question. What's reverse variation? I mean, you can maybe try to guess an answer, and let's see what's hiding back here. The relationship between the length of a driveway and the chance of backing into a mailbox. Okay, that's interesting. We're going to work with, basically there's two main types of variation. There's direct and there's inverse. And then the joint variation is a type of direct. It's also direct. And then combined it has both direct and inverse. So there's basically just those two types, direct and inverse, and a couple of other variations of those variations. We'll start with direct. Example 1, we have y varies directly as x. That also means that y is proportional to x, by the way. Anytime you have something that says y varies directly as x, you can write a formula. So what you want to do is you want to say y equals kx. And k is the constant of variation, which is mentioned right down here. K is the constant of variation. And our job is to find k. So first thing you do is if it's direct, you write this formula, y equals kx. Then you look at the problem and it's going to give you some information. Y is 14 when x is 3.5. Those two numbers go together. So we're going to put them in. We're going to put 14 in for y, bring our k down because we're trying to find it, and then 3.5 for x. Go ahead and solve for k by dividing by 3.5, or 14 by 3.5. And I think I'll bring my calculator up. I haven't pulled it up yet today, so it'll take a minute. You can divide those right now on your own and get it done faster than me. (14) divided by 3.54. Oh, nice. Okay. But we're not done yet. So what we're going to do is second step, is to plug 4 back in for k and write y equals 4x. So this is our equation, our direct variation equation, or function. So this answers writing it and then graphing it. Well, what is that a graph of? What type of function is this? What's the parent function? It's linear, so it's going to be a line. It's already in slope-intercept form. Y equals mx plus b. So what's the b? There isn't one, so that means it's 0. And the slope is 4 over 1. Up 1, 2, 3, 4 over 1. Let's go down 4 and left 1 and draw our line. And that completes this first example. Please do this one on your own. So this is going to be y equals kx again because it's varying directly. And I have a pair here that go together so they can both go in. 6.5 will go in for y, bring the k down. 13 will go in for x. 6.5 divided by 13. I'm sorry, it's the end of the day. I am not going to attempt to do that in my head. It's around a half. Yeah, it is exactly a half. Well, duh. Yeah, I knew that. K equals a half. And y equals 1/2 x. See, we want to plug that k back in. So this is the direct variation equation. And then it wants us to graph it. Once again, anytime it's direct variation, it's going to be a line. It's always true. And again, the y-intercept is going to be 0. And it has a slope of 1/2. So starting at 0, we're going to rise 1 and run 2. Go down and left, down and left. Here it is, our line. Not only that, we're never going to have a plus b out here either, so it's always going to go through the origin. try this one on your own as well. So method number 1 is find k. That's what we've been doing all along. It says the circumference of a circle varies directly as the radius. So this right here tells us how to set it up. C equals kr. Then we have a pair. We have a c and r pair. So when c is 7 pi, we don't know k. R is 3.5. And then we can divide both sides by 3.5. 3.5 divided by, or 7 divided by 3.5 is 2 pi. And just write it as 2 pi. You don't need a decimal there. We can leave it exact. But you do have to go back and plug that back in up here and get your final equation. C equals 2 pi r. Wow! Now doesn't that look familiar? Isn't that indeed the formula for circumference? Yay! Oh, but we're not done. Now it has another question. Find r when c is 4.5 pi. So now we're going to use this formula to answer a question. It's kind of like the exponential growth and decay. On those problems we had to find k, and then we were able to use the equation to answer a question. Same with this one. So I'm going to be plugging in 4.5 pi into my formula here for c equals 2 pi r. I'm just plugging it in and bringing the formula along. And guess what? My pi's are going to cancel, right? Because I can divide both sides by pi. So those are gone. And I've got 2r equals 4.5, so I'm going to divide by 2. And that's 2.25. So r is equal to 2.25. And do we have units? Yes, we do. We have feet. Okay. Not bad, huh? Now, you guys did this last year in geometry down here. Oh, come back. We don't want you. Now, it does say use a proportion, method number 2. So we'll go to a new color. And I did say earlier that when quantities vary directly, that they are also proportional. So that means you could say r is to c as r is to c. Sorry. Or c is to r as c is to r. It doesn't really matter what you do. So, and what am I doing? I'm finding r. So the one I'm trying to find, I'm going to put it on top. So find r when c is 4.5 pi. So I'm going to say r is to 4.5 pi, because these two pieces of information are paired together, as, and then I'm going to do the similar pair on the other side. I have an r on top, so I need the r on top, and the r was 3.5 feet, and that paired with 7 pi on bottom. So I have r over c equals r over c. When you're making proportions, remember you have to keep things aligned. Now, guess what? Those pi's are going to cancel again, because you can undo the pi's by multiplying both sides by pi, and guess what? That's going to go, and that's going to go. So I've got r over 4.5 equals 3.5 over 7. I just saw those pi's and wanted to cancel them out. If you didn't see that, you could have cross-multiplied it at the beginning, but I'm going to cross-multiply right now. So this is going to be 7r equals 3.5 times 4.5. And then before I multiply those together, I'm going to just go ahead and divide by 7. And then I'm going to do that in my calculator all at once. 3.5 times 4.5, hit enter, get an answer, then divide by 7, get an answer, 2.25. And our units are feet. And that looks familiar because that's also what we got when we did it the other way. If you had left these pi's in, like if you had decided not to cancel them at the beginning, maybe you didn't notice that, which is fine. Say they were originally there. Let me just show you really fast that you would have gotten the same thing, because if you cross multiply, you'd have 7 pi r equals 3.5 times 4.5 pi. And then at this point you would divide by 7 pi, and these pi's would cancel out there. So regardless of which order you do it in, those pi's will cancel. Now, you could try this one on your own. I'm seeing we have a dodecagon. Do you remember what that is? Dodecagon, that has 12 sides. So try this on your own. Perimeter varies directly as the side length s. So P equals KS. And then we can plug our information in. Perimeter is 18. S is 1.5. Then we're going to find K, divide both sides by 1.5. I probably should know what that is, but I'm just going to do it and make sure I don't make a mistake. 12. K is 12. Then we put that back in, so we've got P equals 12S. So there's the formula. That's kind of like the first task. Now find S when P is 75. So we plug 75 in. This is the second task. Plug 75 in for P. And find S divided by 12. Well, I know that's going to be S is the side length. That's going to be some kind of decimal. 6 point something. 75 divided by 12. 6.25. And we have units, we have inches. So we found S when P is 75 inches. Make sure you include units with your answers, show all your work, all that good stuff. Example 3. Okay, now we're going to do joint variation. Joint variation is still direct. So, but instead of it being direct, like before we just had two variables, now we're going to have an additional variable. So it says the area A of a triangle varies jointly as the base and the height. So we still start it the same way. A equals KB, just like before. But then we have this additional variable H. We just multiply it to the B. So that's how a joint one sets up. And then it's going to proceed the same way. A is 12. B is 6. Okay, the K comes down. H is 4. Solve that. That's going to be 24. So I'm going to be dividing both sides by 24. And that's going to be 1/2. So K will equal 1/2. That's step 1, finding K. Then we're going to plug that back in. Just for K. The BH are still BH. Oh, that looks like the area of a triangle. It is. I wasn't even paying attention, was I? Area of a triangle, right there. Here it is. Area of a triangle. Sorry. It's the end of the day and I'm yawning. Oh, okay. Put that away. Talking about the flipped classroom. Let's see. Sorry, I got off track. So now we have found the equation. Now we're going to answer the next question using the underlined information. So when A is 36, I'll plug in 36 for A, bring down my 1/2. We're finding B, we don't know what it is, and then H is 8. So right away I'm going to simplify the 1/2 times the 8, that's going to be 4, so we'll bring along everything else, 36 equals 4B. Now we undo undo the 4 by dividing both sides, and that's 6. And we have units of meters. Please look and make sure you get the units correct. So we answered the question. Here's the area of a triangle. And here's just a little summary here, down here, of joint variation. So this one's also joint. Please try this one on your own. The lateral surface area L varies jointly, so that equals K times R times L. And then they give us some information. L is 63 pi. We don't know K. We do know R. And we do know L. 63 pi equals 18 times 3.5, which is 63K. Oh, nice. Divide by 63. Those got cancel, and K is pi. It's a nice K value. So we'll take that and plug it back in and get our equation. L equals, replace the K with pi, R, L, or little l. That's the first task, getting the equation. Second task is, we're right here now. Find r to the nearest tenth, and they give us L, big L and little l. So I'm going to come over here to my function. I'm going to replace big L with 8 pi, and then I've got this pi, and I don't know little r, and little l is 5. So I need to solve for r. I'm going to be getting rid of the 5 pi by dividing both sides by 5 pi. That kills those out of there. These pi's die off. We got 8/5 is our r. Check for units, they are in meters. Radius is a length, so it's just going to be 8/5 meters. Okay, 3. I'm just kind of checking to see how we're doing here. We're doing good. And now we're moving on to the third variation, which is really, well, inverse, because in my mind, direct and joint are both really direct. But the inverse is different. When something varies inversely, it looks like this. Y equals k divided by x. See how this one is different from the first two that we learned? Because it's division now. So you start with this when it varies inversely. And then y is 3, so now we'll proceed just like we did before, plugging in our information here. So y is 3, k we don't know, x is 8. And this time to solve for k we have to multiply both sides by 8. Dies off. We've got 24. K is a constant. We put the 24 back in the equation for k, and we get the equation. And now in this case, it's not asking us to answer a question. It just wants us to write the equation, but it also wants us to graph it. Well, yeah, you could type it in your calculator, right? But you know what I was thinking about doing is graphing the pairings. It's faster. I think I will. You can type this in your calculator easily enough. I don't want to do that. I want to show you the parent. Let's call it g of x. The parent is just 1 over x. It's called the inverse function. So this is a new parent graph that I am introducing you to. Meet this parent. And let's make a t-chart. I'd like you to do this by hand with me in case you ever need to do it on your own. This is a graph that you should try to remember to, along with the other parent graphs. It comes up a lot in mathematics, especially if you continue on to pre-calc and calc. We use it all the time. I'm going to do my negative. I think I'll do -3, -2, -1, 0, 1, 2, 3. So I'm simply plugging in -3 for x. So that's going to be 1 over -3, or -1/3. This will be -1/2, -1 over 1. 1 over 0. That's going to create a problem, right? That's a number over 0. That's no, that's not happening. So it's undefined. 1 over 1, 1 over 2, 1 over 3. Let's put those babies up here. We got -3, 1, 2, 3 is down 1/3. Back 2, down 1/2. Back 1, down 1. 0 is undefined. So we'll talk about how to graph that, how to represent that on here. 1, 1, so over 1, up 1. Over 2, up 1/2. Over 3, up 1/3. Well, look at that. This is like nothing we've ever graphed before. It does not go like this, by the way. It's not connected, actually. It turns out that where this is undefined is an asymptote. So let's draw it in with a yellow, beautiful yellow dashed line. You can see that right against that purple. And we know that asymptotes are lines that the graph approaches but never reaches. So guess what? We get to draw this. And by the way, there's another asymptote right here. Let's put that in too, because you can see that one a little better. And you know, as you did 4, 4 would be a 4th. If you did 5, it would be a 5th. It'd be getting smaller and smaller and smaller, right? These points. So this asymptote, y equals 0, is a little more obvious. Now back to this other color. So this way it's going to go right down to that asymptote. It also happens to approach this asymptote vertically. And then this one's going to approach the asymptote there, and this one's going to approach the asymptote there. Now how about that? Isn't that cool? That's 1 over x. That's the parent graph of 1 over x. Let's take a look at before I graph 24 over x, can you think about transformations, what that 24 is going to do to the graph? What transformation is it? Well, it's the same as saying 24 times 1 over x. The 24 out front is a vertical stretch, right? So when I graph 24 over x, I should expect to get a vertical stretch of this graph. So it's going to pull this, well, I can't show you I was doing it with my hands, but you can't see that. So let's just go ahead and graph it. This is so much fun. Introducing you to a new function. 24 divided by x. I'm going to try, now let's try a zoom 6 window. I think, well, it's already defaulted there. You can see it a little bit. Just for comparison's sake, let me go into y2 and do 1 over x, the parent. Take a look at that. See how that 1 over x is real close to the axes? And then the vertical vertical stretch is pulling them up and down vertically. Next. Y varies inversely as x. Okay, I would like you to practice this one on your own. Oh no, never mind, this is a warm-up. We'll do it in class. Skip that for now. This one says the time t that it takes for a group of volunteers to construct a house varies inversely. So I know that's going to be k over x. So time t equals k over the volunteers v. Use the variables that they give you, otherwise it gets too confusing. Now, plug and chug. So we got 20 volunteers. Okay, I'm going to have k over 20. Can build a house in 62.5 working hours, so that's the amount of time. Now we'll multiply both sides by 20 to get our k by itself. And I could probably do that in my head, but I'm tired, so I'm just going to do it on here. 62.5 times 20. 1250. And we'll put that back in here. T equals 1250 over V. That's the equation. So that's step 1, get it in the equation. Now I have to step back to read this. If 20... Okay, here, sorry, I lost track. How many volunteers would be needed to build a house in 50 working hours? So now we're going to use our equation to answer our question. So this is like step 2, or task number 2. The 50 working hours, well, that's time. So I'm going to be plugging 50 in here for t. I want the one that has I want to use my equation I just found that has my k value already figured out over v. Oh, this one. Please pay close attention here on how to solve for v. Anytime you have a variable in the denominator, you have to get it in the numerator in order to solve it. So you have to multiply both sides by v. That's paramount. You have to do it that way. And then, now that it's up in the numerator, I can simply divide both sides by 50. So that kills that. And we'll go to our calculator and just do... Oh, I've already got 1250 in there, so I can divide by 50. 25. And that would be volunteers. 25 people. And that's all that one needed. Well, we are cruising right along. So this is kind of the second major thing here, or maybe third. Solve direct variation and inverse variation equations for k. So what we're going to do is use for direct, that one's y equals kx. So start with that. Now solve that for k. So to get k alone, I have to divide both sides by x. So that means k equals y over x. Keep that in mind. Let's come over here and do inverse. Well, inverse is y equals k over x. And now we're also going to solve that one for k. In order to get k by itself, we have to multiply both sides by x. Kills that off. k equals x times y. Well, isn't that interesting? So, in direct variation, which is this first one, the blank of the two quantities is constant. So the two quantities are y over x, and that's the quotient of those. You're dividing, so that's the quotient of the two quantities is constant. In inverse, over here, we have x and y being multiplied together, which is the product of the two quantities in question, will be the constant. The constant's the k. So here, the quotient of these two equals the constant. Over here, the product of the two equals the constant. You'll need to know that, by the way. So if you need to go back, pause and write those down. Make sure you know like these statements and this idea here, and you know that this inverse direct. You need to know all that, or at least be able to redo it every time if you don't want to memorize it. And here's how you apply it. Determine whether each data set represents direct or inverse, or neither, by the way. So what we're going to do is we're going to check. We're going to try multiplying them. Oh, you know what I'm going to do before I do this? Let's write down again from the previous slide so we have it handy, the information we just learned. So if it's direct, this is just little side notes. Direct, we had that it's division. It's the quotient, so it's y over x. So k was y over x if you look back. And then if it is, sorry, my brain, inverse, k was the product, x times y. Okay. And I was just going to double check because, you know, when it gets towards the end of the day and I get kind of tired, I don't want to make any stupid mistakes. So direct, I'm just double checking, make sure I got that right. Yes. Okay, so what we're going to do now is we're going to do this. So we can check to see if it's direct by doing the quotient and see what we get. So we're going to do y over x, so that's 9 over 3. This would be 24 over 8. This would be 30 over 10. Well, lo and behold, this is 3, this is 3, this is 3. That means we have ourselves a direct variation because I did the k, we did the quotient of them, and we got these all to be the same number. So that means this puppy right here is direct variation. It's a little counterintuitive because when you set them up, it's y equals k times x. You know, it's like a product. But when you actually have a table of values, you're going backwards to figure out whether it's direct or inverse. So that's why you need to know, or at least be able to generate these two little equations here to help you out. Okay, this one. Let's try see if it's direct again. So we're going to do the y divided by the x. The y divided by the x. The y divided by the x. Well, I can already see these aren't the same. 18 divided by 2 is 9. 3/12 is a fourth. So it's not that. So let's check. So it's not direct. It doesn't match the pattern y over x. It's not y over x equals k. So let's check to see if it's inverse. Well, that's the product of x times y. So let's do the products. I'll just write it here. The product x times y, I'll make like a new little... You could do this too. You could make new little rows under here and figure them out. X times y. 8 times 4.5. 8 times 4 is 32. Half of 8 is 4. So 36. Kind of use the distributor property there. 12 times 3 is 36. 18 times 2 is 36. We have ourselves inverse. Alrighty. Let's see about the next slide. Try these on your own. Okay, let's see here. I want to try the products. You can look at these and kind of get an idea. I'm looking at 15 times 3, so this will be the product, x times y. 15 times 3 is 45. 9 times 5 is 45. 12 times 3 is 36. 3/4 of 12 is 9. 36 and 9 is 45. Okay, the product is the inverse variation. So this one is inverse because when I did the products of each xy pair, I got a constant. This one I'm thinking definitely not the products, because 1 times 0.2 is not going to be the same as 40 times 8. So let's try the y over x. So this is like my new little column. Y is 0.2 over 1, 8 over 40, 5.2 over 26. So this is 0.2. That's the same as a fifth, by the way. I think I'm going to write it that way. 8 over 40, that does reduce to a fifth. And I'm going to guess this reduces to a fifth, but you know what? Let's check it on the calculator. Let's do 5.2 divided by 26. Now we got ourselves 0.2, 1/5. Have I talked about the 0.2s, the 1/5? Every fifth is 0.2, so if you want to do 3/5, that'd be 0.2 times 3, or 0.6. It's handy in real life to know those fifths, by the way. Just comes up. And we got to the last problem here. This is a nice little application, and this one is going to be the combined one. It's going to be both direct and inverse, all in one problem. And like I was saying at the very beginning, you see this stuff in science quite a bit, because things in real life vary directly and inversely, and you need equations to describe them. So if you're going to be a scientist, you need to know this. The volume V of a gas varies inversely, so I need a K over a P, and varies inversely with the pressure, and directly as the temperature. So since we're writing this all in one equation, we do not need another K. The T, because it's direct, it needs to be multiplied to the K. So you need the T on top being multiplied. You need the P on bottom because it's inverse, so it has to be divided. And now we have a combination variation, or a combined variation. Now we go read on a little bit further. A certain gas has a volume of 10 liters. So the volume is going to go in here, 10 liters. I was going to do a unit analysis too. L for liters. K we don't know. Temperature of 300 Kelvin. Oh, see if I do a unit analysis K, I'll put K degrees just so you know it's a degree, not a I know that's not correct. It doesn't actually have a degree in real life. It's just big K. I didn't want you to get it confused with this K. And over a pressure of 1.5 atmospheres. The unit analysis might be a little confusing because, you know what, let's just drop it because I don't want to confuse you. And we're just going to trust that the units are going to work out the way they're supposed to. How about that? Just to keep it simple for you. Because otherwise with those units in there, it looks like too many variables and it's too confusing. So we'll keep it simple. Now we're going to solve for K. This is like being multiplied by a fraction, so we undo that by multiplying by the reciprocal to both sides. That's going to knock that and that out of there. Okay, so I can cancel out one of these zeros and get 1.5 over 30, and that's, we'll just see. Like I said, I don't want to make stupid mistakes and try doing these in my head, and I know I should be doing them in my head, but it's 0.05. So K, 1.5 divided by 30 is 0.05. K is equal to 0.05. And then we need to write the equation, so we go back to this baby, plug in the 0.05 for K. Every other variable comes along. You don't want to change those other ones, because you want just the overall equation that relates all the variables. And I'm just doing a quick double check and make sure I get the same thing I got when I did this before. Yes. Great. Now we're going to use this equation to answer the question. If, new color, red. Where did it go? If the gas is compressed to a volume of 7.5, so now I know my volume, so I'm going to plug 7.5 in for V, and is heated to 350 K, so there's the 0.05, bringing that along, replacing the T with the temperature, what will the new pressure be? And P is right there, looking to be found. The thing I could say about units is make sure at least that the units of these match the units of the ones before at the very least. If they don't match, like if they gave you the temperature in Fahrenheit or Celsius, you'd be in trouble. but they match, so we're good. And to solve this, we need our variable in the numerator, so I'm going to multiply both sides by, this is a times, by p. That kills that. And then I'm going to divide both sides by, get p alone, divide both sides by 7.5. Kills that. And we have this problem right here to do on our calculator. Bring it on over. We've got 0.05 times 350. Hit enter. Then divide by 7.5. Enter. 2 1/3. 0.333 is a third. So pressure is 2 1/3. And then just look up here to see what the units are. It's atmospheres right there. ATM. And I was looking to see this other pressure was 1.5, so it's in the ballpark. It sounds reasonable. Great, we did it. So that was 5.1.